ठीक है, I think it's important to open up your eyes rather than just teaching and teaching. Anyone who is not writing mock, you have no chances of making it to any of the college. और मैं ये अपने एक्सपीरियंस से नहीं, ये भविष्यवाणी कर रहा हूँ, और इसलिए कह रहा हूँ because I know you are not ready to understand. You don't write a mock and you have no chances. You are going for a war without preparing for it. That means you are certainly going to die in a war. The only way, if someone asks me, sir, what is one thing that everyone should do before going for any of the examination? I'll say write mock test. आप हमारी classes attend मत करो चलेगा. You watch recording, absolutely fine. But you don't write mock. I think you are doing the biggest crime. इससे बढ़िया मजाक कोई अपने साथ कर नहीं सकता जितना if you are not writing mock. I have, few days back, the people who got selected, I was interacting with them, and there's a lot of interaction. So people who made it to IFT, people who made it to IIM Ahmedabad, Bangalore, Calcutta, if you ask them, do you know what is the average number of mocks they write? They write 30 to 70 mocks. Some of you may be worried, sir, 70 mocks kaise? Forget about only career launcher. People are also joining the test series of other segments. If you are not writing mock, you have zero chances of making it to any of the great colleges. और मैं जोश में नहीं बोल रहा हूँ, बहुत होश में ये सब चीज बोल रहा हूँ. The way you have been treating mock, it is really bad. I'm recording it. If you are watching it later on in the recording, हाथ जोड़ के आपसे विनती है, mock लिखिए, नहीं तो आपका जीवन मतलब कैट तो नहीं होने वाला, बाकी तो जो मर्जी कर लो आप. कैट क्या मतलब कैट ज़ैट, none of these exams will be there. So please make sure that you are going to write mock. आप इसे request समझिए, advice समझिए, जो भी आपको अच्छा लगता है, order समझिए, but you need to write mock, and you need to come for the mock analysis. If you are not coming for the mock analysis means, see, reason is the best questions are discussed in the mock analysis. They are the one, every question, there's a lot of efforts that we are putting to form a question. So if you are able to do 10 to 15 mock analysis, if we can do that, I think you will be comfortable with it. So जो tiger लग रहा है आपको, ये tiger will change to the small cat, and then only you can win it. So please write mock and come for the mock analysis. बाद में recording में देखना, मुझे कोई problem नहीं है, but mock तो जरूरी है, ठीक है? So I think we can start. We can permutation combination we already did in earlier class. Some part was done. I'm going to cover a few more things here. Let me tell you some formula here now. We are going to talk about the permutation combination because last class we talked about fundamental principle of counting. अगर आपको याद हो, ठीक है? So now it is combination first. I'm going to talk about. Combination is selection. Whenever we talk about the combination is selection. For example, there are 10 MPs. Out of 10 MPs, we want to select 3 for the position of Prime Minister, Home Minister, Defense Minister. Fine. So we want to form a Prime Minister, Home Minister, Defense Minister. So if I say 10C3, 10 में से 3 लोगों को select कर लिया, now we are going to decide from them. और पहले group of ministers बनते थे, GOM कहते थे, अब तो खत्म कर दिया सब कुछ. Group of ministers, out of 10 people, if I want to form a group of 3 ministers, I'll say 10C3. 10 में से 3 लोगों का selection. अब उसमें पहले PM आए, बाद में होम मिनिस्टर आए, पहले होम मिनिस्टर आए, बाद में PM आए, कोई फर्क नहीं पड़ता. मुझे ग्रुप बनाना है. कौन पहले आया, कौन बाद में आया, that is not going to be important for me. If I want to nominate a prime minister, home minister, and defense minister out of 10 people, if you interchange this, Amit Shah and Rajnath Singh, if you are going to interchange their position, I would say that is a different combination. Do you understand? So wherever the arrangement comes, when you interchange their position, whenever the arrangement comes, it is permutation. क्या कहते हैं इसे? Permutation is what it is known as. तो जब भी arrangement होगा, जैसे for example, A, B, C, D, इन 4 अल्फाबेट्स में से एक वर्ड बनाना है. तो ये अरेंजमेंट होगा या सिलेक्शन होगा, क्या बताना चाहेंगे? दिस इज अरेंजमेंट, क्योंकि ABC और ACB और CAB और BAC, all of these are different words. So these are arrangement, means if their position are interchanged, they are going to form a different combination there. Is that fine? That is arrangement. But if I ask you that you need to select 3 friends for the party, does it make any sense that who is coming first and who is coming later on? So out of 5 friends, I want to take 3 of the friends for the birthday party. So I'll say 5C3. किसी भी 5 में से 3 को select कर लो. This is selection. हाँ, अगर मुझे 3 लोगों को select करना है, ठीक है, as a teacher in a class, one should be nominated for maths, one should be nominated for DI, one should be nominated for BA, ठीक है, कोई award के लिए. Now you may be for maths, you may be for DI, you may be for BA. तो जब arrangement की बात आएगी, तो if I'm saying that here it is Anshika Sharma is for maths, Ashwin is for DI, and Ankit Yadav is for BA. If you interchange their position, there will be different combination. So you understand, whenever it does not matter if you interchange their position, I say that is selection. If we are talking about rearranging them, if we are talking about, interchanging their position and a different combination is coming, I'll say that is arrangement. I believe it is clear to all of you. Okay. So now what is the meaning? NCR, out of n people or items, R are selected. This is NCR. Out of n things, R got selected as NCR. This is written as a n factorial upon R factorial into n minus R factorial. This is NCR. Fine. So out of 7, I want to select 3 friends. Listen here, no need to write. I told you take a screenshot. It is 7 factorial upon 3 factorial into 4 factorial. Now 7 factorial can be further written as a 7 into 6 into 5 into 4 factorial. Stop here. Why you should stop here is 4 factorial can get cancelled out from them. 3 factorial is 6. I can cancel, I'll say 35 ways. I can select 3 friends out of 7 friends there for the party. I believe it is clear. So NCR is n factorial upon n minus R factorial into R factorial there. ठीक है, कोई डाउट है तो पूछ लीजिए. Over to you. स्क्रीनशॉट ले लीजिएगा. कोई भी डाउट हो पूछ लीजिएगा. Anything. Okay. Come to the next part of it. Out of 10 friends, I want to take 1 for a movie, another for a cricket match, IPL match कर लो, खतरनाक है, ठीक है, and 1 is for swimming. So I will say out of 10 people, I want to select 3 people. And then I want to arrange 3 people in 3 into 2 into 1 ways. Or directly I can say I am arranging 3 people out of 10 people. My dear, 10C 3 ways are 10 factorial upon 3 factorial into 10 minus 3 is 7 factorial. Once 3 friends are selected, I can decide, okay, out of 3 friends, this has 3 options. He can go for movie, IPL match, swimming. 3 options are there for the first friend. The second friend is having only 2 options क्योंकि एक के साथ movie देखा है, आप दोबारा नहीं ले जा सकता. So 2 options. And the last 1 option. That's why we are saying it is 3 factorial. So it is 10 factorial upon 3 factorial into 7 factorial into 3 factorial. I can cancel out it. The answer comes out to be 10 factorial upon 7 factorial. So what is 10p3? It is 10 factorial upon only 10 minus 3 factorial, which is 10 factorial upon 7 factorial. So there is no 3 factorial coming in the denominator. It is 10 factorial upon 10 minus 3 factorial. So my dear, NPR is n factorial upon n minus r factorial. Sometime we also write NPR is n में से r लोग select कर लो, फिर उनको arrange कर लेना. एक ही बात है. They are same thing. Come on, have a look at this. Ask me if there is a doubt. Any one of you? Clear? किसी को कुछ पूछना है तो पूछ लीजिएगा, ठीक है. So I think it is clear. Now I want to tell you some formulas here. There are 10 benches in a room and I want to conduct a test of 3 students. The condition is these 3 students should not be sitting at consecutive benches. I hope you understand. The benches are, say, bench number 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there, 9 is there, and 10 benches there. There are 3 students, A, B, C. I want them to sit on these benches such that no 2 people will be sitting on consecutive benches or together. ऐसा भी नहीं है कि एक ही को 3 bench पे बिठा दो. They are appearing in a test. So what I do is, rather than taking this one, I will say fix ABC. The number of benches that I'm going to put before A is A. The number of benches between A and B is B. The number of benches between B and C is C. And number of benches after C is D. The total number A plus B plus C plus D, 3 people have already occupied 3 benches. How many benches are left? 7 benches are left. I need to put in these 7 benches at these 4 positions. Where A and D is greater than or equal to 0, you may be making someone sit on the first bench. So इससे आगे वाला कोई भी bench ना पड़ा. You may be sitting at the last bench. After that, there is no bench left. But B and C must be greater than or equal to 1. Do you understand this? Because there must be 1 bench empty between A and B. There must be 1 bench between B and C. After C, there may be 5 benches left. There may be none of the benches left. So I don't know what is that value. I'm saying it is A and D are greater than 0 and B and C are greater than or equal to 1. Have a look at this. पूछिए अगर कोई doubt है. 3 benches have been already occupied by A, B, C. The number of benches before A is A. Number of benches in between A and B is B. B and C it is C, and after C there are D benches. The sum of the benches is coming out to be 7 because 3 benches have already been occupied by these 3 gentlemen A, B, C. How many ways I can do it? ठीक है, तो A and D is greater than or equal to 0, B and C is greater than or equal to 1. अब एक फॉर्मूला दे रहा हूं मैं आपको. Distribution of n identical things in between are distinct things. मतलब you are distributing it among the different number of people. No 2 humans are same, but are distinct things. लिख लीजिएगा. Is n plus r minus 1 CR. So what I know here is A plus B plus C plus D is equal to 7. आपने कहा सर ये दोनों कम से कम एक होना चाहिए. मांग रहे हैं तो दे दो ना यार दोनों को एक. क्यों लड़ाई करना? -2. Give them 2. So only 5 needs to be distributed. Anyone can be now greater than 0. Why? They wanted 1. I said 1 1 चाहिए ना, दे दो उनको. So out of 7, 2 of them are given to them, 5 are left. Can you distribute 5 identical chair in between 4 different positions? I'll say 5 plus 4 minus 1 C4 minus 1. Your answer is 8C3. This is the ways in which I can make 3 people sit in such a way so that no 2 of them are sitting together or at the consecutive benches here. Is it clear? Have a look. Ask me if there is a doubt. कोई भी दुविधा हो पूछ लीजिए. एक तो मुझे नहीं पता कितना लैग है, इसलिए भी मैं वेट करता हूँ. हालांकि मुझे बहुत आलस आता है. ठीक है. एंड या सिद्धार्थ से आई डू दैट. और अगर आपको डाउट हो तो पूछ लीजिएगा प्लीज. Siddharth, what we are saying is I want to distribute 7 benches at 4 different locations. First location and last location is greater than or equal to 0. 0 onwards you can put anything. Means 0, 1, 2, 3 you can put anyone. But इनके बीच में कम से कम एक बेंच होना चाहिए. तो एक बेंच तो इनको चाहिए. B and C must be at least 1. हमने कहा एक बेंच चाहिए, डाल दो ना यार उनके बीच में 1 1. So 5 benches not to be distributed. Anything can be greater than or equal to 0. तो मैंने आपको फॉर्मूला बताया था डिस्ट्रीब्यूशन ऑफ n आइडेंटिकल थिंग, क्योंकि बेंच तो एक जैसे between are distinct thing, क्योंकि लोकेशन डिफरेंट है इसलिए are different things. So I will say 5 benches need to be put in at 4 different location. That is this, which comes out to be 8C3, my dear. Is it fine now? Clear here? Find the number of solutions where number of integral solution means they must be integral value, where this is the condition. Come on, can you get the answer now? Okay, Anshul. Anyone else? Any answer? A plus B plus C is equal to 8. देखिएगा जरा. A कम से कम 1 होना चाहिए, दे दो यार मत. B कम से कम 1 होना चाहिए, give 1. C must be 2. So give them. How much is left? 4. I want to distribute now 4 in between A dash, B dash, C dash, where all of them are greater than equal to 0. ये formula तभी लगेगा जब value greater than equal to 0. So I'll say distribution of 4 between 3 is this. That is what? 62. 15 ways. Is it fine? Have a look. Ask me if there is a doubt here. ठीक है? One more thing I would like to cover here. किसी को डाउट है तो पूछ लीजिएगा. Steffi, you want me to explain it again? Steffi, I want to distribute 8 mangoes between 3 people, A, B, C. A said that I want at least A and B want at least 1 mango to be there. C says at least 2. Ma'am, they are asking for 1 mango. Why don't you give them 1 mango? Why don't you give 1 mango to B as well? C wanted minimum of 2. I give whatever is the minimum requirement, I give them. Now I'll say all of these 3 values, I change their values. All of them are greater than equal to 0. So I'll say distribution of 4 identical things, 4 mangoes. Mangoes will be identical. ऐसा नहीं है लंगड़ा चौसा आप कह रहे हैं. So you will be saying that 4 mangoes need to be distributed between 3 people. I'll say 4 plus 3 minus 1, C 3 minus 1. This is the direct formula. Distribution of n identical things between r distinct things is n plus r minus 1 C r minus 1. I believe it is clear now. कुछ पूछना है पूछ लीजिए. ठीक है स्टेफी, clear till this point? Say one day 10 ministers were supposed to deliver a speech. They were supposed to deliver speeches where PM is supposed to speak before Home Minister is supposed to speak before External Affair Minister or Foreign Minister. Okay. There are 7 more ministers. They can come at any of the place. I'm not saying Prime Minister speak just before Home Minister. आप मुझसे पहले बोल रहे हो, क्या पता आपके और मेरे बीच में 2 लोग हैं. So Prime Minister speaks before Home Minister speaks before Finance Minister. How many ways 10 minister can deliver their speech? Fine, come on, try it. अब सोचिए, मतलब मैं तो आंसर एक ही बार में दे दूंगा, but you also need to think on it. Very nice, Christian Tripathi and Steffi. I don't think so. This is the answer. Here we go now. Now, I want everyone to please pay attention here. Siddharth Sinha, no, 120 will not be the answer. Listen now. How many people are there? There are 10 people. How many ways they can deliver a speech? At first position, 10 में से किसी भी एक मंत्री जी को बुला लीजिए, वो deliver करेंगे. Second, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. So 10 people can deliver a speech in 10 factorial ways. I want 10 people, 10p, 10 is 10 factorial upon 0 factorial. By the way, 0 factorial is 1. Your answer is 10 factorial. Arrangement है, Home Minister पहले बोल रहा है, Defense Minister बाद में बोल रहा है. Is a different combination than Defense and Home Minister. Internet unstable. Should I repeat it? Okay. There are 10 people, they are going to deliver a speech. In how many ways can this be done? At first position, any of the 10 can come because everyone is allowed there. They can forget about this Prime Minister, before Home Minister, before Foreign Minister. So any of the 10 can come there, then any of the 9 people can come there, then any of the 8, 7, 6, 5, 4, 3, 2, 1. 10 factorial is answer. I can say I want to arrange 10 out of 10 people. That is 10 factorial upon 0 factorial, which is also 10 factorial. आपने कहा सर लेकिन आपने तो क्वेश्चन ये दिया था, ये तीनों अरेंज नहीं होने चाहिए. 10 of the people are arranged in 10 factorial. I want those 3 not to arrange. They can arrange in 3 factorial ways. Just divide 10 factorial by 3 factorial and you will get the answer. I believe it is clear. Well done, Krishna Tripathi. So if someone asks you that there are 10 people, they can arrange in 10 factorial. I don't want them to arrange, but they are arranging in 3 factorial. Don't take that. Here is your answer. Is it fine, clear now? सवाल पूछना आपका जन्मसिद्ध अधिकार है, पूछिए.
Sir, how are we taking the 3 factorial in denominator? How are we finding that these 3 will be arranged in 3 factorial?
Fine, Anshul. Anshul, you know, this carries all possible combination. Anyone can come first and then anyone can come later on. But I know whatever may happen, Prime Minister, Home Minister and Finance Minister, their order should be this one. Means these 3 people, if the order is not given, they can arrange themselves in 3 factorial ways. You said, no, I don't want them to arrange. I want only one case. They are arranging in 6 ways. So what I did is I divided because it is multiplying in this case. So I need to divide by 3 factorial. That is the reason why this is the answer. Ritika ji, now is it clear, Anshul?
Yeah. Okay.
Clear? Jasween?
Yeah.
हाँ जी. उसमें वही केस होगा जो हमें प्रूफ करना है. हाँ. So I don't want Prime Minister, Home Minister, Defense Minister to arrange themselves. ठीक है. Prime Minister, Home Minister and Foreign Minister to arrange themselves. They can arrange themselves in 3 ways. Let me take one case. Let's take Prime Minister, Defense Minister, Home Minister and Finance Minister. sorry, foreign minister, where prime minister speaks before home minister speaks before finance minister. Fine. Can I say they are speaking in one way only? This defense minister can come at one place, two place, three place, four places. Four ways are there. Four people can arrange in 4 factorial ways. I don't want them to arrange. If you divide it by 3 factorial, don't you think that it gives you the same answer? There are 4 ways which are coming. So that is the reason 10 things can arrange in 10 factorial, but 3 of them cannot arrange. I want them to be only in one particular order. That's why we are dividing by 3. Now I think it is clear. Very good. The question has been asked, what if the prime minister, home minister and finance minister are there? And A number of people are there, B number of people are there, C number of people are there, D number of people are there. Is it the question? Now, what I want is A number of people are going to come there. Are they oranges? Are they chocolates? Are they identical? They are ministers. No two humans are same. Even they are look alike. Then also they are not same. So the formula that we are going to apply here is not similar one. The reason is very simple, because they are not identical. Okay, so you cannot say दो मोटे मंत्रियों को यहाँ डाल दिया. अरे भाई मोटे मंत्री हो सकते हैं, but they will be different. I believe it is clear. That's why I will not be using that. I think I have already told you, distribution of n identical things. They need to be identical. Anyone else having any query? I think it is clear now. Ritika Gupta ji, Sanyaya. Jobin, is it clear? Ankit Yadav, Nandini Bhardwaj. Thank you. Let's come to the next. This part is also done. I think these questions are done. Could you please confirm it? Was it done in previous class? Yes. Was it also done? This was not done. Let's do it now. You want a matrix A, B, C, D, E. You know, the sum of row and the column is coming out to be 4. So I know 4 of them will be 1 and 1 of them will be 0. Here I will write, I cannot write 0 under it. I will be writing 1. Then I can write it like this. Then I cannot write 0 under it. Fine. So in how many places 0 can come in first? Any of the 5 places? Then in second place, I can put 0 here, or I can put it under here. I can put under here. Any of the 4 places? 3 place, 2 place, 1 place. I'll say 120 ways is your answer. Is that fine? Clear? Have a look at this. पहले मैं 0 किसी भी पोजीशन में रख लेता, मैं ऐसे भी लिख सकता. अब you are putting 0 in second column, in second row when you are going to form. I can put 0 here, or I can put 0 here, or I can put 0 here, or I can put 0 here. Of course, at other places, all of them will be 1. So I'll say the second 0 will have 4 ways, 5 ways, and 4 ways, and 3 ways, and 2 ways, and 1 way, which is 5 factorial, which is 120 ways. Have a look, ask me if there is a doubt. कोई भी दुविधा हो पूछ लीजिएगा. Yeah, Jobin, I can repeat it. Jobin, what we are saying is that I am forming a 5 by 5 ka table such that every entry is either 0 or 1. You can only write a digit 0 and 1. But the sum of the row and column is coming out to be what? 4. So I know in first row I can put 1, 1, 1, and one of them should be 0. But this 0, I can write the first row like this, or I can also write it in this, or I can write it in this form, or I can write it in this form, or I can write it in this form. So there are 5 ways I can pick up the first row. If you talk about the second row, which is coming here, I cannot write 0 at the fifth column. I can put it at 4th column. I can put it at 3rd column, 2nd column, 1st column, or I should, एक जगह तो आना ही है. So I'll say 4 methods. I can write it 1 1 1 0 1. I can write 1 1 0 1 1. I can write 1 0 1 1 1. I can write 0 4 times 1. So there are 4 ways I can do it. And the next one, because the 2 questions are given, out. Now it is 3 places I can put 0, 2 places I can put, 1 place I can put it. It is 120 ways. Is that fine, clear now, everyone? Okay. कुछ भी कोई दुविधा हो पूछिएगा. ठीक है जो. Thank you. Oh my God, let's come to this question. In how many ways can 8 distinct fruits, अलग-अलग लिखे हुए, including apple, banana and mango, be kept in a row such that apple always come before banana and banana always come before mango? Come on, fast. Fruits are distinct, लिखा हुआ इसमें distinct fruits है. तो ऐसा नहीं है कि साथ के साथ बनाना है. I'm sure 8 of the fruits, distinct fruit, can arrange themselves in 8 factorial ways. I don't want them to arrange divided by 3 factorial. Third is correct answers. Very good, Anshul Rathi and Ankit Yadav. The answer is very simple. We just did it few seconds ago. Is it fine? Please ask if there is a question.
Sir.
Come on, write it. No, no Ankit, no Ujjwal. Someone else has also written the answer. Anshul Rathi nahi hai. 3 cases to nahi banenge. Here I go now. What to say? This question is similar to this question. There's no difference. This one is similar to the Prime Minister one question. Now, how are this? I can pick up any of the 10 digits, 9 digit, 8 digit. How many ways 3 numbers can be formed, even when 0 can also come there. So I'll say that is 720 ways are there. I don't want them to arrange because this is the largest number. So no need to worry even about the 0. I'm saying, sorry, don't arrange them. This number is larger than this number. This number is larger than this number. 3 factorial answer is 120 ways. That's it. क्या कुछ समझ में आया ये? Ashwin, Ujjwal, Ankit, Anshul Rathi.
Sir?
Yes.
Sir, like I'm a little confused about this division of 3 factorial. Like what exactly is the concept behind dividing it when we don't want to arrange them?
Yeah, the concept here is, ma'am, there are 3 numbers A, B, C. In how many ways can you arrange them? You will say these are 3 factorial ways I can arrange them. Let's take 2 more people with them. I'll say A, B, C, D, E. But A said that I will come before B and B will come before C. I know there are 5 people who can arrange themselves in 5 into 4 into 3 into 2 into 1. Anyone can come at any position. That is 5 factorial. In this, A, B, C are also arranged in A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. They are arranging in 6 ways. And others, and means multiplication. These 6 ways are multiplying with something else. I don't want these 6 ways to come there. So I'll say 5 factorial by 6 will be your answer, which is also known as the 3 factorial by the way. So that will give you 20 ways there. Is it fine, Steffi ji now?
So, sir, like basically, whenever we do not want to do a particular arrangement, we just have to divide it with the
Yes.
corresponding. Oh, okay, sir.
Yes.
Got it.
Why we are dividing it? Good, you are asking these. A comes before B and B comes before C, and D and E will come. You remember I told you wherever and is coming, we are multiplying. That means 3 factorial is multiplying with these values there. Look here, I'm putting A, B, C. Let's prove it in the reverse order. I'm already putting these 3 people there. Where can D come? D can come at this place, this place, this place, this place. The 4 places D can go there. Fine. What about the other one who is going to come there? So 4 places, अगर मैंने आपको इनके बीच में place रखा, you can say that he can also come at the 5 different places. क्यों जी? इसके पीछे आ सकता है, यहाँ आ सकता है. तो जहां पर भी ये आया है, इसके लिए जैसे for example, I'm saying D is here. So E can come at 1, 2, 3, 4. These are the 4 places where E can come. I believe it is clear. Then you are putting D here. So uske liye 1, 2, 3. 3 places it can come. Then you put D here. You can say 2 places are there. And then finally it is 1 place. So rather than doing all these calculations, I will say 5 people can arrange in 5 factorial. I don't want these 3 people to interchange their position. They are going to come in only one way. So I'll say divided by 3 factorial. That is what is your answer here. Clear now? Any doubt here?
Yes, sir, this is clear. But sir, like I just want to ask you something. So like
Yes.
I'm not sure if it's a correct concept, but like this ABC, it's like one arrangement, right? Basically,
Yes.
like having. So why can't we just combine them and make it one arrangement, and then
Very
along with
nice
that we
question.
can add that?
If you combine this, ma'am, so you will take only one possibility, that is A, B, C, and D. You can say D, A, B, C, and E. You can say D, E, and A, B, C. As I'm saying, A comes before B, B comes before C is a different case than A comes just before B and B comes just before C. This is the case that we are taking when A comes just before B and B comes just before C. But the case that I'm taking is in between A and B, even D can come. In between B and C, even E can come. That is the reason why I'm not considering this case.
Okay, sir, got it, got it.
Fine. Anyone else? Any more query? Yes. I have been asked a question that why did I take 10 into 9 into 8 here? I think this is the question. If you are taking even 0 here, you are taking 1 here and 2 here. When you are saying this digit needs to be greater than this digit need to be greater than this digit. So there 3 factorial will give you only the case when 2 is greater than 1 is greater than 0. So you should not be worried about it. You cannot write a 0 here, but that will be eliminated because it is given that this is larger than this was larger than this one. So that is the reason why 10 into 9 into 8, I'm taking all these possibility and then dividing by 3. Automatically that get cancelled out. They will be coming in only one order. I believe it is clear to all of you as well. Okay, let's try to solve this question now. Question number 14. Be fast. Yes, Siddharth, please ask me what is the query. Good, Anshul. सिद्धार्थ क्या डाउट है आपको क्वेश्चन नंबर 13 पे? सिद्धार्थ हम कह रहे हैं कि हम कोई भी 10 डिजिट यहाँ ले सकते हैं, कोई भी 9 डिजिट ले सकते हैं, कोई भी 8 डिजिट ले सकते हैं, सारे पॉसिबल कॉम्बिनेशन, इवन दिस कॉम्बिनेशन, इवन 037, even 098, all of these combinations are fine. These 3 number can arrange themselves in 3 factorial. मैंने कहा बिल्कुल नहीं चाहिए मुझे यहाँ, क्योंकि जब 0 1 2 आएगा तो I want it to be 2 1 0 because this number needs to be greater than this. So when they can arrange in 3 factorial ways, I want only one way, that is 2 1 0 can be there. Do you understand it? So I'm saying any of the 10 9 8 number can come there, and these 3 numbers should not arrange. I don't want them to arrange. So that's why we are dividing it by 10 factorial. So 10 into 9 into 8 divided by 3. Now why I'm saying, because there may be a case of 4 5 6 coming there. So I'll say in that case 6 5 4 is the only possibility. Of 4 5 6 so likh nahi sakte. Yes, 3 number have been selected. When you are arranging them, any of the 10 number can come, 9 number can come, 8 number can come. Divided by, I don't want them to arrange. On left hand side you got a larger value. Being a larger value, you cannot be 0 here. So इसलिए वो ruled out हो गया. Siddharth, is it clear now? Thank you. I've been asked the question, what if it is in descending order? So I will take total cases minus the cases which starts with 0. So I'll say the 0 is fixed here and the rest of the 9 digits can be 9 into 8 divided by 2 factorial. That will give me the answer. I have been asked question, what if it is not the left digit, that is the smallest digit? I'll say take all number 10 into 9 into 8 divided by 3 factorial. This will carry a case when it starts with 0. So I'll take up all those number which start with 0. If 0 is fixed here, any of the 9 number can come, any of the 8 number can come. Divide by 2 factorial. Minus 9 into 8 divided by 2 factorial will be your answer in that case. Where left digit is lesser than, middle digit is lesser than right digit. Is it fine? So I will still consider all cases, but I will separate the cases which starts with 0. सिद्धार्थ आपको समझ में आए? ठीक है. Okay, Krishna Tripathi has given some answer. Here I go. Sorry, don't have much time. There are 6 players need to be selected out of 11 players. 2 particular players are selected. 2C2, जो 2 लोग हैं उनको select करो. And out of 9, I will select 4 more people. You know, any NCN is equal to 1. So 2C2 is 1. Answer is 9C4 for this. Two particular players are never selected. So I'll say out of 9, I need to select any 6 people. That is your second answer. Khatam, batao kya problem is? Two particular players should not be coming. So 11 people are there. I need to select 2 of them. So out of 11, 2 are gone. So 9C6 will be the possible case for second. Please ask if there is a doubt. So first answer is 9C4, second answer is 9C6. Anubi, should I explain B? Ma'am, there are 11 players and you don't want A and B to be selected. So 2 are gone. So 9 players are left. Out of them, you want to select any of the 6. So can I say 9C6? Because selection to 6 ka hi hona hai. ठीक है. Try to answer this, everyone, now. No, in that case, if you are taking Krishna, if you are taking total cases minus 2 cases of above 1, it is given that both of them are not selected together, but one of them can be there. Do you understand? If I say total minus cases when you two cannot come together, तो आप अकेले तो आ सकते हैं ना? So it will give you the different answer, my dear. ठीक है, बहुत बढ़िया. Okay, there are 5 eclairs, 4 Kit Kat, 3 melodies, and 7 more chocolate in which all are distinct. ये चीज ध्यान रखिएगा, अलग अलग है. ठीक है. Find the number of ways in which a child can select one or more chocolate. One or more chocolate. So can I say 5 eclairs can be selected in how many ways? Can anyone tell me? There are 5 eclairs. In how many ways I can select a chocolate, at least one chocolate from there? You need to answer that one only. There are 5 eclairs. In how many ways I can select? I can select chocolates from these 5 eclairs. One or more chocolate can be selected. How many ways? 0 way. क्यों? अंशुल राठी अलग-अलग तो नहीं है यार, सब एक जैसी है तो 5 फैक्टोरियल तो नहीं हो सकती. ऐसा नहीं करना, पहले 5 में से कोई एक आएगा, फिर 4 में से एक आएगा, फिर 3 में से कोई एक आएगा. All of them are identical. See, I select 1 eclair or 2 eclair or 3 eclair or 4 eclair or 5 eclair or 0 eclair. मैं लेते नहीं, मुझे eclair पसंद ही नहीं है, दांत में फंस जाती. So should I say there are 6 ways I can select or not select any of the eclair? How many ways are there? There are 6 ways. इसमें एक way वो भी है, मैं eclair नहीं लेता, मैं तो Kit Kat खाता हूँ यार. So should I say that way is also included here? And what about Kit Kat? There are 5 ways. What about melodies? 4 ways. What about these 7 chocolates? First chocolate, there are 2 ways. Second chocolate, 2 ways. Third chocolate, 2 ways. 7 times I'm going to write. 1, 2, 3, 4, 5, 6, 7. Very good. Now, this include a case when I'm not eating any chocolate. ये तो पाप है, बिना कोई chocolate खाए मैं कैसे रहेगा कोई? So I will separate that case when neither eclair is selected, nor Kit Kat is selected, nor Melody is selected, or none of these chocolates are selected. So separate that one case here. So what is my answer? My answer is 6 5 is 30 into 4 is 120. 120 into this is how many times? 7 times. So 32, 64, 128 minus 1. So 0, 12 8 is 96, 12 2 is 24 plus 9 is 33. So it is 15,316 minus 1 is 15,359. Total cases are 15,316. This include a case when I'm not taking any one of the chocolate. They are saying you have to take at least one. Anshul ji, is it clear now? Ujjwal? Yes. Six ways include कर दिया. Six way में एक way वो भी तो है जब zero eclair is selected. 5 way में वो भी तो है जब zero Kit Kat is selected. 4 में वो केस भी तो है जब zero Melody is selected. 2 केस में पहली चॉकलेट लूं या नहीं लूं तो zero of that chocolate. 0 0 0 none of those chocolates are selected. So one case is when I'm not taking any of those chocolates. So don't you think because in the question it is asking a child can select one or more chocolate? Jobin, these are 7 different type of chocolate. उनके नाम नहीं मालूम A B C D E F G chocolates are there. Either I take it or I don't. 2 ways. I take it, I don't. 2 ways. And because it is independent on this, I select this or not. This or not, this or not, this or not, this or not. So there are 2 to the power of 7 ways are there. Is it fine, Jobin, my dear? I'll not say 7 plus 1. They are not identical. If they are identical, I'll write 8. किसी और को कोई दुविधा कुछ पूछना चाहे? Then in that case, you will take at least one eclair is there, or one Kit Kat is there, or one Melody is there, or one of the A chocolate is there. Don't you think it will be too lengthy if you are going by this method? तो इसमें से सारे केसेस ले लो, उसमें से एक ही केस तो घटाना है यार जब मैं कोई चॉकलेट नहीं खा रहा. That will be sufficient. Let's come to this question now. Okay, got some answers. So Aman Garg, good to see your reply. कल तो तुम reply नहीं कर रहे थे. Anshul Rathi, Krishnan Tripathi. Okay. So there are 4 married couples in a club. Stop writing it. 4 married couples means 8 members are there. The number of ways of choosing a committee of 3 members so that no couples appear in committee. There are 4 males, 4 females. What are the possibilities? I'll take 3 males from here, or I will take 3 females from here, or I'll take 2 males but not their wives. So here 1 female is coming, or I'll take 1 male and 2 females, of course not his wife. These are the cases which will be coming. So out of 4, 3 can be selected in 4C3. Committee बनानी है तो कौन पहले आया कौन बाद में आया उससे कोई फर्क नहीं पड़ता. I'll double it. Why? Because 4C3 will be also in female. Here also out of 4 I can select 3 people. No? 4C3. This is also 4C3. I'll double it. Mango plus mango is 2 mangoes. Okay. Here out of 4 I select any of the 2 males. Now if these 2 males are selected, I will be selecting any 1 female out of them. So can I say out of 2 female I select 1 male, 1 female, or out of 4 males I select 1 male, and out of 3 female I select 2 males, 2 females. So if you look at it, it is 4 into 3 by 2 factorial into 2. That is coming out to be by 2. That comes out to be 12 ways. And this is 4 into 3 is also 12 ways. So you know this is same thing. It is identical. It is symmetrical. So 12 plus 12 is 24. Plus 8 is 32 ways are there. So I'll say in 32 ways we can select it. Answer is option number 4. I believe it is clear, everyone. Anshul, समझ में आया? Aman, Krishnan Tripathi. Very nice. Here it is given. I'll say it is first any of the 8 people are selected 8 ways. Second, I will not select his wife, so there are 6 people selected. Then there are 4 people selected. Very good. This is correct. But when you are selecting people one by one, it is also talking about arrangement. पहले आप आए, फिर मैं आया, फिर और आए, so this carries arrangement. 3 things are arranging themselves in 3 factorial ways. You need to divide it by this. Answer is 32. See the miracle, it is matching. दोबारा बताता हूँ. 4 चॉकलेट हैं, 4 चॉकलेट में से different type of chocolates, say A, B, C, D are the name of those chocolates. I want to select 3 chocolates. So select. तो 4C3 आ गया, 4 ways. What I do is पहली जगह में कोई भी 4 में से, फिर 3 में से, फिर 2 में से. Now you can understand this. I'm taking them one by one means it is an arrangement because this is different from 4 ways. So I need to, these 3 should arrange themselves in 3 factorial ways. Your answer is 4. Good that you asked me this question. Clear, Jaswin? पूछिए please, कोई doubt है? Anyone? Nandini Bharadwaj, Anshika Sharma, Sumit Wakmare, Steffi. Clear? Yes, no, कुछ तो बोलो, लिखो. Okay. How many sets of 2 distinct numbers can be formed using the number 0 between 0 and 180 inclusive both, such that the average is 16? Chalo, you try out this. Okay, so most of you are getting 60 as the answer. Ujjwal, Anshul, no, not Anshul, Krishna Tripathi, Aman Garg, Ashwin, and Ritika got this answer. Anshul is saying none of these. So how many sets of two distinct number? Acha, you tell me if I say two numbers are there, their average is 60. Can I say some of them will be 120? मुझे नहीं लगता इसमें किसी और कोई प्रॉब्लम. So 0 and 120, 1 and 190. This goes till 59 and 61. These are 60 combination. One combination will be of 60. But two distinct numbers are given. Anshul Rathi, is it clear? So that is the reason none of these 61 cases nahi banenge here. There are 60 cases which are going to form. Fine. I believe it is clear to others. So with 0, 120, this is first. 119, this is second. 218, it is third. This goes on till 59 and 61. So 0, this is first case, this is second case, this is third case, so this is 60th case. This is how you get to it. Well done, others. I believe it is clear now to others as well. Sumit, आपको समझ में आए? Siddharth Sinha. Okay, let's try to do it. Let me tell you first a concept here. You know, a plus b to the, I toss a coin. Let's say I toss a coin. What do I get? I get a head or a tail. I toss it one time, you will say head, Hindi mein ya, Angrezi mein or tail. So I'll say two cases are there. When I say you are tossing a coin two times, so first possibility is I will get both the time head. So it is h, it is h square. My internet connection is showing unstable. I'm repeating it again. When I toss a coin once, one coin is tossed. You get either head or tail. So I'll say two cases are coming there. Fine. When I toss a coin two times or two coins are tossed, एक ही बात है, एक coin को दो बार toss करो या दो coin इकट्ठा toss करो. I'll get both heads, or I'll get first head, second tail, or first tail, second head, or both of them are tail. So I'll say it is h square लिख लेते हैं इसको, and two times I'm getting one of them is head and one is tail, and second is t square. Two times I'm getting both of them to be tail. यही होता है a plus b का whole square is a square plus twice of ab plus b square. I'm sure all of you are aware of it. So if I want to find out the cases, what should I do? I'm not interested in head or tail. I'll put h is equal to t is equal to 1. So I'll say 1 plus 2 plus 1, 4 cases are there. देख लीजिए 4 cases बन रहे, 1 2 3 4. यहाँ पर if you put h and t is equal to 1, I'll say 2 cases are going to form. When you are tossing a coin 3 times, what are the possibility? All 3 times I get head. Out of 3 times, 1 time I get a tail and 2 times I'm going to get a head. 3c1 का होता 3 में से एक बार. Out of 3, 1 time I'm getting a tail, and the rest of the 2 time I'm getting a head. I believe you agree with this one. 3c2, out of 3 times, 2 times I'm getting a tail and 1 time surely it is coming out to be head. 3c3, out of all 3 times I'm getting all 3 tails, there's 0 head. So this is written as a h cube plus thrice of th square plus thrice of t square h plus t cube. This is similar as a plus b का whole cube. अगर आपको थोड़ा बहुत आता है a cube plus thrice of a square b plus thrice of ab square, then it is b cube. Do you agree with it? This is how we are doing the expansion. Now someone asks you how many cases are going to form. I'll put h is equal to t is equal to 1. This gives me what? This gives me 1 plus 3 plus 3 plus 1, which is 8. You can also put 1 1 here. I'll say 1 plus 1 ka cube is also 8. So it is satisfying. Is it fine, clear here now? अब देखिए, आराम से देखिए. Ask me if there is a question. And take a screenshot as well, because I'm going to erase it now. Any query you can ask. I think I can erase it now. ठीक है जी, आगे आइए. कुछ और भी बताना चाहता हूं आपको. NCR is equal to NCN minus R. मतलब 5 ले लेते हैं. There are 5 books. 5C0, I can select 0 books. I can select 1 book. I can select 2 books. I can select 3 books. I can select 4 books. I can select all 5 books. 5C. What is 5C0? Look at this. 5 factorial upon 0 factorial into 5 factorial. What is 5 factorial? 5 factorial upon 5 factorial into 5 minus 5 is 0 factorial. Can I say they are equal? Let's talk about 5C1. That is 5 factorial upon 1 factorial into 4 factorial. What is 5C4? 5 factorial upon 4 factorial into 1 factorial. They are also same. Let's talk about this. 5 factorial upon 2 factorial into 3 factorial. What about this one? This is 5 factorial upon 3 factorial into 2 factorial. They are also same. What does that mean? The first term is same as the last term. Second term is same as the second last. Third is same as the third last. So NCR is equal to NCN minus R. Take a screenshot of this as well. Ask me if there is a query. पूछ लीजिएगा. ये मत सोचिएगा घर जाके क्लियर होगा, बाद में जाके क्लियर होगा. मुझे नहीं लगता मेरे अलावा कोई क्लियर करवा पाएगा. सॉरी. सुमेध, तुम्हें समझ में आ रहा है? यू आर नॉट रिप्लाइंग माय डियर. 2-3 बार तुम्हारा नाम बुला दिया, बट यू आर नॉट रिप्लाइंग. आई होप यू कैन हियर मी माय डियर. उज्जवल, आर यू देयर? ठीक है. देखो, उज्जवल हैज ऑलरेडी रिप्लाइड. अनुभी, अंशिका शर्मा, okay, thank you. Ankit Yadav, Anubhi. Anshika, are you there? That means Sumedh has just switched on it and is watching on Netflix. Must be. The second is Anshika. Anshika ji, you are also not there. Recording देखेंगे तो बाद में समझ में आएगा आपको क्या. ठीक है, here I go now. So I hope this concept is clear. A student is allowed to select at most. At most means maximum of n books can be selected from a collection of 2n plus 1 books. Fine. So either I select or I reject a book, and there are 2n plus 1 books. Fine. Do you understand? There is first book, select or reject. Second book, select or reject. And third book, select or reject. And fourth book, select or reject. And this happened 2n plus 1 times. So I'll say 2 cases are there, 2 to the power of n plus 1. Fine. So if I say out of 2n plus 1, I write C0, 0 of them selected, 1 selected, 2 selected, 3 selected, n selected, n plus 1 selected, n plus 2 selected. I hope you understand. ऊपर नहीं लिखा, इसका मतलब 2n plus 1 है. You imagine it. बहुत सारा time waste नहीं करना. So it is 2n plus 1, C2n, and finally 2n plus 1, C2n plus 1. Can I say this is same as this one? This is same as this one. This is same as this one. Is separate. The sum of 0 and 2n plus 1 is how much? 0 plus 2n plus 1 is how much? 2n plus 1. Sum of 1 and 2n is what? So I hope you understand that. What is sum of n and n plus 1? So I'll say I will break it from this. So 2 to the power of 2n plus 1 is equal to twice of. Why? Because the first half is equal to second half. C0, C1, C2, C3, C4, Cn. Because maximum of n books are to be selected. Have a look at this. Ask me if there is a query. If I expand this, it is 2 to the power of 2n plus 1. I know the book gets selected as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, goes till n. I know the sum of the first half and second half are equal. So I have broken C0 to Cn is the first half. The second half is also same, twice of that. it is saying at least one book needs to be selected, means this C0 is not there. So what I will do is 2 to the power of 2n plus 1. If I divide it by 2, I'll get it as a C0, C1, C2, C3, C4, Cn, which is 2 to the power of 2n. Because if this goes up, it is minus 1. 2 to the power of 1. When goes above, it is minus 1. This get cancelled out. 2 to the power n is equal to C0, C1, C2, C3, Cn. You said at least one book is to be selected. I want to select this one. Can I say C1, C2, C3, C4, Cn is equal to 2 to the power of 2n minus 1. What is that given? That is 255. So 2 to the power of 2n minus 1 is equal to 255. 2 to the power 2n is equal to 256. My dear, it is 2 to the power of 8. It implies 2 to the power of n is equal to 8, n is equal to 4. Find the value of n. My God, it is 4 here. Have a look at this. Ask me if there is a doubt. Yes. There are n plus 1 books are there. Every book may be selected or rejected. And there are 2n plus 1 books. If I want to find out the cases, few seconds back, I told you R is equal to S is equal to 1. So the total cases are 2 to the power of 2n plus 1. I'm not interested in selecting and rejecting. I'm interested in cases which is 2 to the power of 2n plus 1. Is that fine everyone? देखिए आराम से पूछिए कोई डाउट है तो.
सर जब टोटल केसेस 2 की पावर 2n plus 1 है तो उसमें सिर्फ एक ही केस तो ऐसा होगा सर जिसमें सब रिजेक्टेड होंगे.
जिसमें सब
रिजेक्टेड होंगे सर.
हाँ, और इसमें वो भी केस होगा. लेकिन इसमें लिखा है एट मोस्ट, यार ये भी तो लिखा है एट मोस्ट n बुक. मतलब आई डोंट वांट n plus 1 बुक, आई डोंट वांट n plus 2 बुक, आई डोंट वांट n plus 3 बुक आउट ऑफ 2n plus 1. तो मुझे मालूम है फर्स्ट हाफ एंड सेकंड हाफ दोनों बराबर है. x आ रहा है तो 2x आ गया. इज इट फाइन?
नहीं सर, इसका जो सेकंड सेंटेंस है, इफ द टोटल नंबर ऑफ वेज इन व्हिच शी कैन सेलेक्ट एट लीस्ट वन बुक इज 255. सो इसके अंदर 2 की पावर 2n plus 1 minus 1 255 के बराबर नहीं होना चाहिए.
-1 कैसे किया?
वन ऑप्शन तो हाँ, वन ऑप्शन वो हो गया ना सर जिसके अंदर सब रिजेक्टेड है. सर टोटल हमारे पास ऑप्शन हो गए 2 की पावर 2n plus 1.
हाँ जी.
एक ऑप्शन वो हो गया जिसमें सब रिजेक्टेड है तो वो हमने माइनस कर दिया.
नहीं नहीं नहीं, सब रिजेक्टेड नहीं है. सब नहीं रिजेक्टेड होगा. एट मोस्ट n बुक्स कैन बी सिलेक्टेड. n plus 1 भी रिजेक्टेड है, n plus 2, n plus 3, n plus 4, n plus 5 till 2n plus 1. Total books are 2n plus 1. Maximum of n books got selected. तो जो आप नहीं लेना चाहते वो n plus 1 से लेके 2n plus 1 तक नहीं लेना चाहते सर. समझ में आ रही है?
नहीं, अगर सर हम इसका सेकंड सेंटेंस देखें, उसके अंदर लिखा है द टोटल नंबर ऑफ वेज इन व्हिच शी कैन सेलेक्ट एट लीस्ट वन बुक इज 255.
हाँ, एंड उससे ऊपर भी लिखा हुआ है बुक a student is allowed to select at most n books.
ओके ओके, वो दोनों कॉम्बिनेशन ठीक.
हाँ, दोनों कंबाइन लेना.
ठीक.
और कोई डाउट? एनी वन ऑफ? Question number 19. Say 5 people are A, B, C, D, E. The number of people coming before it is A, B, C, D, E, F. A plus B plus C plus D plus E plus F. How many people are there? Out of 12, 5 people are already sitting. Ye बैठे हुए. So 7 people are left there. Where A and F is greater than or equal to 0, but B, C, D, E are greater than or equal to 1. So if they are 0 and these 4 are 1, I will separate this. I will say it is 3. If 1 is given to them, 1 is given to them, and 1 is given. So I'll say A plus B dash plus C dash plus D dash plus E dash plus F. Because why 1, 1 is separate. Distribution of 3 between 6 thing is this. So that is 8C2. 28 ways are there. Fine. Now listen here. The number of ways of selecting 5 persons is that no 2 of them are consecutive. I have already taken these cases. But you know, these are humans. So in how many ways they can further arrange themselves? So I know the 7 of them. I believe it is clear to you. Okay, they are selected. They are like this particular way that they are going to be selected. Okay, so that no 2 of them are together. So can I say it is coming out to be 28 ways are going to come there? जरा देख लीजिए पहले इसमें. ठीक है. Can we further multiply because these people can also arrange themselves? So I'll say they are 5 factorial more is to be multiplied. That is your answer. Let me tell you again. There are 5 people. Say the 5 people are sitting like this. I need to make them sit in such a way. Indirectly मैं कह रहा हूँ 5 लोगों को ऐसे बैठाओ कि कोई भी consecutive position में ना आए. हमने ये रखा. हमने कहा at least this should be 1, this should be 1, this should be 1, this should be 1. आपने कहा sir total 7 people है, 3 of them, 4 of them should be sitting there. So only 3 are left. How can we distribute these 3 people at 6 different locations? 3 plus 6 minus 1. Okay, and plus R minus 1, C R minus 1. Sorry, this was 6 minus 1. And plus R minus 1, C R minus 1. So ये कितना आ गया आपका? This is 6 plus 3, 9 minus 1 is 8C7. 8C5. So it is 8 into 7 into 6 upon 3 factorial. That comes out to be 56 ways are there. 56 ways are here. Sorry. We have taken this is the to be taken here. So it is 6 minus 1 that is going to come. 56 ways are there. Now, can I say humans can also arrange? Yes. But even if they are arranging, I'm saying the number of ways of selecting 5 people. So selecting means I select first this one or then this one, or I am going to exchange, that is coming out of the same case. So selection ke case mein no arrangement will come because you are selecting. I'm making them to sit in this way. So 56 will be your answer. I'm so sorry. It is 56 coming. No arrangement because I don't want first A to come, then B, or BA will be 2 different combination. Nahi hoga. Because you are selecting. You remember I told you out of 10 ministers you want to select 5. Anyone can come at any of the position. It hardly matters to us. So from there I will get this. I believe it is clear. Please ask if there is a doubt. उसमें तो हम ये वाला मेथड लगाया नहीं था ना. हमने तो we because they want to come in this particular order, we were dividing it by 3 factors because we don't want them to arrange in particular way. Here you are selecting them. You can do that same thing here. Match करेगा कुछ. हाँ मैच करेगा, बिल्कुल मैच करेगा. Where I go? Where was that question? You can cross check that. I think we discussed it. Fine. Is it clear? Everyone take a screenshot. Do let me know whether it is clear or not. Why? Because the selecting 5 people are there. Whether A select first, then B select, or B select first and then A select is the same case here. So no need to arrange them. Otherwise, I need to arrange the values as well. Fine, clear. Let's come to the next one. In how many ways three numbers can be selected from a set of 43 consecutive natural numbers such that their sum will be multiple of 3? एक concept बता देता हूँ आपको. दुनिया में कोई भी नंबर या तो 3n की फॉर्म में होता है, 3 का मल्टीपल होता है, या तो 3n minus 1 होता है, या 3n plus 1. For example, the number is 1, 2, 3. I'll consider it as a 3n plus 1. I consider this as a 3n minus 1 because I can write it as a 3 minus 1. And I consider it 3n. 4 belongs to 3n plus 1, 5 belongs to 3n minus 1, 6 belongs to 3n. 7 belongs to 3n plus 1, 8 belongs to 3n minus 1, 9 belongs to 3n. This is how it will be going on. Fine. Now you can do, the numbers are given from 1 to 43. You pick up 3 numbers. No arrangement, you pick up 3 numbers such that the sum is divisible by 3. How can you solve it? Come on. Okay, here I go. How many numbers are there? You know, had it been 42, so I would have divided 14 types of numbers are there of each type. But I know the first number is 3n plus 1, so these are 15 numbers. 14 number and 14 number. Please do ask me. 14 3s are 42 होता. अगर 42 numbers होते तो सारे बराबर type के होते. जो first number होता है natural number, that is 1. That means the last number will be also 43 is 3n plus 1. So I'll say 3 plus 1k, there are 15 numbers in this form, 14 are in this form. I can select any 3 out of 14. I can select any 3 out of 14. I can select any 3 out of 15. One case is that. I can also select one number from 3n plus 1 and one number from this and one number from this. Don't forget to divide by 3 factorial. क्यों याद है जब मैंने कहा था आप 1 by 1 number लेते हो तो it is talking about the arrangement as well. So don't forget to divide by 3 factorial. Summation of that will be your answer. Check कर लीजिएगा. 14 से 3 होता है 14 into 13 into 12 upon 3 factorial which is 6. ठीक है तो इसका डबल हो जाएगा. So it is 14 2s are 28 into 13. 13 8s are 104, 26, 36, 364 ये cases आ जाएंगे. डबल करोगे तो 728 आ जाएगा. 15c3 is 15 into 14 into 13 divided by 3 factorial, that is 6. 3 5s are 3 2s are. So it is 35 into 13. 13 5s are 65. 39 plus 6 is 45. I'll say 445 cases. Add कर लीजिएगा. 1183 are the cases coming there. Don't forget this. It is 3n. Sorry, कितने थे ये? 14 C1 is 14. 14 into 15 divided by 3 into 2 into 1. 3 5s are. This is so 35 into 14 is the value which is coming. 14 5s are 70. 14 3s are 42 plus 7 490. Add कर लीजिएगा, you will get the answer. I believe it is clear to all of you. Yes, no, clear. Okay. So this, there are 3 numbers to be selected such that their sum will be always a multiple of 3. One case, all 3 of them are all 3 of them, all 3 of them. And the last case is one of these number is to be taken. Let's come to the next one. What are the possible number of ways of select three number from 1 to 15 natural numbers such that selected number are arithmetic progression? Arithmetic progression अगर आपको मालूम नहीं है जिनके बीच का difference same होता है. These are the three numbers that is to be selected. So first 15 natural numbers are 1, 2, 3, 4, 5, 6. Till 15. Can I say they are in AP? First case, second case, third case, and the last case are there are 13 cases which are formed. All of them with a gap of 1. Can I say 1, 3, 5? Can I say 2, 4, 6? Can I say 3, 5, 7? And this goes on. The last number is 15, 13, and 11. So how many combinations? There are 11 cases coming. Then I'll take the gap of 3, 1, 4, 7, 2, 5, sorry, 2, 6, 10. And this is the last number with a gap of 4, it is 11. With a gap of 4, it is 7. Fine. Sorry, 3 ka gap hai. So 3 ke gap mein it is 12 and this is 9. So 9 cases are there. By now you are able to understand that there are 13 cases, then 11, then 9. So only odd numbers will be going to come there. I'm sure you are not going to do beyond it. So it is 14, 14, 14. 3s are 42 plus 7 is 42 plus 7 is 49, which is 7 is square is your answer. वैसे आपको एक और फॉर्मूला बताता हूँ. Sum of odd number n odd numbers is coming out to be n square. So 1 plus 3 होता है 2 का square. देख लो जरा. 1 plus 3 plus 5 होता है 9, which is 3 का square. So 1 plus 3 plus 5 plus this goes up to 13. So I'll say there are 7 numbers, so 7 ka square. Is that fine? Clear everyone? Ask me if there is a doubt. Sorry, we have very limited time. और मुझे अभी ये permutation 1 ही complete नहीं हुआ. That's why I'm taking more of the question. Next. Geometry, all of you have done in which regular polygon the number of diagonal is double the number of sides. You know, polygon, there are n vertices. How many sides will be there in polygon? N sides will be there. So if out of n I connect any of the two vertex, say I'm connecting the vertex. So I'll say either this is side of this polygon or this is coming out to be the diagonal of polygon. So NC2 is telling you about the NC2 is the number of ways in which you connect any of the 2 points. I believe it is clear. Fine. So NC2 is out of n points, 2 of them are connected. जितने number of vertices होते हैं उतने ही number of sides होते हैं. If you subtract n from there, you will get the number of diagonals there. There are 6 A, B, C, D, E, F. 6 vertices, 6 sides are there. If you connect it, 3, 4, 5, 6, and 7, 8. 8 of them are coming. 6C2 कितना होता है? 6 5 is 30 by 2 is 50. Minus 6 of them are to be subtracted, तो 9 of them will be formed. ठीक है, तो देखो ये 9 है क्या? तो हर एक के साथ कितने हो गए? 1 2 3. तो 6 3s are 18 diagonals are coming. But A connect with C or C connect with A is the same thing. If you divide by 2, I'll say 9 diagonals are there. Is it fine? With every one, there are 5 points with which it is connected. 2 of them are already signed. So I'll say 3 diagonals are there with A. 3 diagonals are there with B. I believe it is clear. So all 6 of them are connected with 3 diagonal. I connect with you, you connect with me is the same thing. So there are 9 diagonals. I believe it is clear to you. So it is NC2 is n into n minus 1 divided by 2 minus n is equal to double the number of sides 2n. So I'll say n into n minus 1 divided by 2 is equal to 3n. I'll cancel n here. N minus 1 is equal to 6, n is equal to 7. What does that mean? If n is equal to 7, this gives you what? Heptagon. Yes, you are right. N is heptagon, 7 is heptagon. Is it fine? Ask if there is a question here. This is the standard formula to find out the diagonals as well. NC2 minus n is the number of diagonals. क्या कह रहे हैं 5c2 minus 5 क्यों पेंटागन के लिए हाँ so 5c2 minus 5 will be the number of diagonal 5 fours are there 5 diagonals that you are going to have fine डबल नहीं है ना इक्वल है now you can find it I have already discussed question number 22 it is very similar to that one come on get the answer okay here I go इधर देखिएगा थोड़ा the diagonal of a convex hexagon intersect at n distinct point inside the hexagon there's a hexagon I just discussed if you connect any of the 2 points it is -6 is going to give you the number of diagonals so 6 5s are 30 by 2 is 15 minus 6 is equal to 9 diagonals this diagonal this diagonal this diagonal these are the diagonal fine these are the diagonal if I expect 9c2 आप 9 में से कोई भी दो diagonal ले लो they will be intersecting at one point ठीक है like this will be intersecting with this only at one point ठीक है हाँ 9 होने चाहिए fine so this is how we are drawing it so it is convex one which is given that ऐसे बाहर से 180 of course regular है तो 120 ले लो तो बाहर का angle will be 360 minus 120 which is 240 so can I say 9c2 out of 9 you pick up any of the two diagonal let them intersect so I'll say 9c2 is there so it is 9 into 8 upon 2 so 36 point of intersections will be there okay what is the maximum value of n can take n distinct point they intersect the diagonal of a convex hexagon intersect at n distinct point inside a hexagon so 2c1 ये दोनों लिए और उनका 1 point of intersection आता है ठीक है now what I want is what is the maximum value of n can take just a second minus 6 if I'm not right 9 9 8 is 36 are the points sorry this is coming out to be 36 n can take what is the maximum value of n can take is 36 this comes out to be 36 points will be there where they will be intersecting 1 2 3 on one it is 1 2 3 and 1 2 3 3 these are 27 the answer will come out to be 36 here 1 2 3 4 18 are answer 6c2 minus 6 is number of diagonal are 9 out of 9 diagonal I pick up any two diagonal let them intersect so I'll say 9 into 8 by 2 that comes out to be 9 4s are 36 you know ways I can select two diagonal and make them intersect okay fine sorry now this intersect with this one or this intersect with this one is the same case this intersect with this one and this intersect with this one is coming out to be same case. I need to divide it further by 2 because I want to find out the points there. So I'll say 18 points will be coming inside that. Is that fine? Let me explain it again. 9C2 is out of 9. I picked up any 2. So 9C2 is, but when they're going to intersect, this point intersect with this one, this point intersect with this one is coming out to be same. क्योंकि जो 9 होगा, जो पहले वाला होगा, it is going to intersect with 8. The second is going to intersect with 8. So there are 72 with whom they are going to intersect. Divided by 2 is coming out to be 36 here. Now they are talking about the number of distinct points. नहीं यार 36 ही आएगा क्योंकि हर एक point one diagonal is going to intersect with 8 different diagonals. ठीक है? Okay. The problem is that these diagonals are intersecting here, which is considered as a vertex here. Because if I'm taking this diagonal, they are not intersecting. This diagonal, they are not intersecting. ठीक है जी, सही है. Sorry. So here there are 3 diagonals. They are not going to intersect with each other. They will be intersecting at the vertices. I believe it is clear. So can I say one diagonal is going to intersect with how many diagonals? 3 diagonal of this. I believe it is clear. Look here. Sorry. 9, not everyone is intersecting at the middle point. These 3 diagonal, look at any of the diagonal which is coming out from a vertex. It is not intersecting with other diagonals. Fine. This, sorry, they will be intersecting with other diagonal, but not with each other. जैसे इस वाले vertex से है, they will be intersecting at this. With this vertex, they will be intersecting with this. So can I say one diagonal is going to intersect with the 6th diagonal? One diagonal is going to intersect with 6. 9 of them are going to intersect with 54. And then you intersect with them. This is coming out to be 27. Fine. Now let's talk about this one. ये इसके बगल वाले सारे diagonal के साथ intersect करेगा, but are there some diagonal with whom it is not intersecting? With all, yes. This is also the one with whom they are not intersecting. तो इसमें cases बनाने पड़ेंगे यार. It is very tedious one. Look here. The one is going to intersect with 3 cases. Then it is going to intersect with, this is going to intersect with 3. This is going to intersect with 1, 2, 3. This is going to intersect with 3. So everyone is going to intersect with 3. I'll say 6 into 3 is 18. The 18 will be the possible cases which are going to come there. Is it fine now? Have a look at this. Sorry, if you are talking about a diagonal, they will be intersecting at a vertex. These are the diagonals which are going to intersect at the vertex. I want the internal point of intersection. I want to find out these point of intersection. So if I talk about the 3 diagonals which are going from it, it is going to intersect with the other. So I'll say this is going to intersect with the 3 diagonals of it. Is it fine? So everyone is intersecting with 3, 3, 3. So I will multiply it with the 6 3s. 18 will be the cases. I intersect with you, you intersect with me is the same case. So because of that reason, 18 will be coming out to be your answer. Have a look at this. Why 9C2 is not applicable? Because of diagonal which is coming from one point, they are not going to intersect in between. They are going to intersect only at the vertex. I believe now it is clear. Please write a yes if it is clear, write a no if it is not yet clear to you. Come on fast, everyone. There is a hexagon. There are 9 diagonals which are going to form. Is it clear till this point? There are 9 diagonals that we are going to form. Okay, these are the diagonals. And with this, with this. Fine. I'm sure all of you can see these are the point of intersection. I intentionally did not intersect them here. So what we get from here is, yes. Now look at this diagonal. Every diagonal is going to intersect with the 3 of the other diagonal. How many diagonals are there? There are 9 diagonals which are going to intersect. You can see this one. This one is also going to intersect with this 1, 2, 3. What about this one? The longest diagonal is going to intersect at 4 points. This diagonal is going to intersect with 3 points. This diagonal is going to intersect at 4 points. So I know if I'm talking about everyone is intersecting at 3 points, 9 of them are going to intersect with 3 points. 9 3s are 27 divided by 2 करा, आपने कहा 13.5 आया. तो जो भी होगा, this will be more than 13. ठीक है. Now what does that mean? There are few diagonals which are going to intersect at the 4 points. These are the diagonals which are coming there. ये वाला diagonal भी आएगा, इसके देखो 4 point of intersection आएंगे. तो जो longer वाले diagonal है उनके 4 point of intersection आएंगे. There are 4 diagonal which are, yeah. Yes, there's a doubt. Agree to this one? So we know that they are going to intersect at the 3 points here. तो 6 3s are 18 तो बनेगा ही बनेगा, और आप मेरे साथ इंटरसेक्ट करो, मैं आपके साथ इंटरसेक्ट करूं, it is coming out to be, sorry, 9 3s are 27 is coming there. Now there are some diagonal which are going to be more. तो कितने ऐसे diagonal होंगे जो longest diagonal होगा हर एक का एक. तो 6 के कितने हो गए? 6 के there will be 6 diagonals which are coming there, which are going to give you the finally some more points there. ठीक है. तो 9 3s are 27 are the total points, plus आपने क्या दिया 6 के, this will be coming out to be 6. What is this? Just a second. Sorry, 9 के 9. So that comes out to be 36. A intersect with B and B intersect with A is the same thing. So you are going to divide it by 2, which is coming out to be 18 here. I believe this is clear now. This is how you can do it. I can also do 9C2, but I need to separate the cases when they are intersecting at the vertices. मुझे वाले cases भी इसमें से separate करने पड़ेंगे. Do you agree with it? Anyone, any doubt?
27 तक तो ठीक है, हमने जो 9 सम किया.
9 कैसे किया? See, when you are looking at this long diagonals, you will be finding more point of intersection. 1, 2, 3, 4. There are 4 point of intersection which are coming. Similarly, if you are talking about this longer one, you will be also finding out the 4. So almost everyone is going to generate one extra point of intersection. One एक point extra आएगा. That is how you can do it. उसके अलावा कोई इसमें कोई, of course if they are intersecting at one point, then it is coming out to be 27 आपका आंसर होगा. ठीक है. But अगर ये ज़्यादा आएगा, because they are convex. Convex means कि ऐसा नहीं है कि they will be intersecting only at one point. They are spreading. So that means they are going to generate some more point of intersections there. Is it fine? Fine. You need to count up these points then. मैं देखता हूँ कुछ और कोई shortcut लगता है इसमें. But this is how it should be done. वैसे ये होना चाहिए था 9C2, and then we need to separate these points, but I don't think that is going to make a sense here, because 1, 2, 3 of the diagonals are meeting 3C2. So 9C2 is coming out to be 9 into 8 by 2, which is 36. So the point of intersection will be coming out to be, 9 8 is 72 by 2 is 36 is coming there. 3C2 आप separate करेंगे तो -3. But उसमें फिर 6 vertices are coming. 3C2 is this. 6 of them are coming there. 6 3s are 18 हो गया. You will get answer as a 18. ऐसे भी कर सकते हैं. Let me repeat it again. 9 में से कोई भी 2 इंटरसेक्शन कर लो. आपने कहा ठीक है सर, 9 में से कोई भी 2 इंटरसेक्ट करेगा. 36 cases are forming there. Now, but 3 of them are intersecting at one point. So 3 में से any 2 of them are intersecting. I will say that is one point. That is not separate point. That is vertex. It is falling on vertex. It is not coming inside it. वो कह रहा है ना, inside the hexagon. So I'll say 3C2 is what I'm going to separate. That is 3 cases are coming there. Into 6 vertices are there. So I'll say 36 minus 18 will be coming out to be also 18 there. You can also go by this way. Will that work? I find out all point of intersection. I subtract those point of intersection where all of them are intersecting not inside but on the hexagon. So 3C2 is there and every vertex is there. ये 6 vertex है. These are 6 vertices. So those 6 vertices, there will be points which are coming there. उनको आप separate कर दोगे. Will that work now? See, when it is a concave hexagon, so what is going to happen is it is like this type of hexagon. You know, because this angle is coming out to be less than 90 degrees. In that case, your diagonal may not be intersecting. See this, you remember that one? This is convex figure where the outer angle is more than 90 degree, 180 degree, it is convex. This is concave. Why it is concave? Reason is the angle is coming out to be less than 90 degree, less than 180 degree. So whenever a figure is like this, these type of figure are coming there, the diagonals will not be intersecting in that case. That is the reason why they have given a convex hexagon. Clear? Anyone? Okay. Let's come to the next one. 52 playing cards. Try out these questions. Let me take one question here. How many arrangement of the word sleepless will no two S appear together? So you got S. How many S are there? There are 3 S. How many L's are there? There are 2 L. How many E's are there? There are 3 E's. And yes. So how many arrangement of the word where no two S appear together? They are saying no two S appear together. Forget about S. Just take L and E's. How many of these alphabets are there? 5. Can I say 5 of them can be arranged in 5 into 3 into 2 into 1? Now these two, if they interchange with each other, it is not going to form a different word. The same word will be coming there. एक L को अगर मैं दोनों L को interchange कर दूंगा तो same word ही बनेगा. If I interchange these 3 E's, the same word is going to form. I'll cancel this. I'll say this is coming out to be 10 ways. Now in 10, how many places you can put S? How many places you can put S? Can I say 6 places? Out of 6, I can select any of the 3 places there. So my answer is coming out to be 63. That is 6 factorial upon 3 factorial into 3 factorial into 10 will be your answer. So what do I get? 6 factorial is 6 into 5 into 4 into 3 factorial. 1 3 factorial get cancelled out with it. 1 3 factorial is 6. 5 4s are 20. 5 4s are 20 into 10. So you can cross check with your answer. देखिएगा कौन सा वाला आंसर है इसमें से. 5 3 factorial 2 factorial 10 ways are coming there. Out of 6, any of the 3 places I can put 63. That is absolutely fine. That is 3 factorial into 3 factorial. So that comes out to be 6 into 5 into 4 upon this is 20 into 10. 200 ways are there. So check कर लीजिएगा किसमें ये आंसर मिल रहा होगा. I think this is the one. 6 into 5 into 4 divided by 3 factorial. क्रॉस चेक कर लीजिएगा इसको या just 5 of the letters can be arranged in 5 factorial already used. 2 of them cannot be arranged. Okay, sorry, there's P as well. So there's one P as well. So I'll say it is 6 factorial upon 3 factorial into 2 factorial. And out of 7 places, I can select at any of the 3 places. Sorry, there's P as well. I forget to take, there's one P as well. So that comes out to be 7C3 into 6 factorial upon 3 factorial into 2 factorial. That will come out to be your answer. So आप check कर लीजिएगा इसको. 6 into 5 into 4 into 3 factorial. एक बार देख लो क्योंकि आंसर मैच नहीं कर रहा शायद मेरे ख्याल से ये factorial वाले तो. And 7C3 is 7 into 4 into 7 into 6 into 5. And this is 4 factorial get cancelled out. 3 factorial is 6. This get cancelled out. And 6 5s are 30. 32s are 60. 60 into 35. So I'll say this is 2100 is your answer. First one is correct answer. I'm sure now you understand this one. Sorry, we forget to take P. That is the reason why it was not matching. Our answer was coming out to be 200. There's one P. So P and 2L and 3 E's. 6 of the alphabets can arrange in 6 factorial ways. 3 of them are same. 2 of them are same. 7 places are left there. Out of 7 places, at any of the 3 places, S can come together because I don't want these S to come together. So I'll say 7C3 are the locations which are to be taken here. And that will give you answer as a 2100. I believe it is clear now. किसी को कोई doubt है तो पूछ लीजिएगा. Try out these questions. I'm sure you can answer this Look at the last question here, question number 30. If the 9 elements are there, look, 2 A's, 3 B's, 4 C's are there. How many ways any 7 elements can be chosen? कितने तरीके से हम 7 elements we can select? So what I'll do here is, I'll say what are the cases can be chosen. लिखा है तो arrangement नहीं है. So what are the things that you cannot, that you will leave, you will not select? I may not be taking 2 A's, I may not be taking 2 B's, I may not be taking 2 C's. Do you agree? I may not be taking AB, I may not be taking AC, I may not be taking BC. So how many cases are there? So 6 ways are there. Is that fine? If you are talking about selecting 7, why should I select 7? How many ways I can reject 2? So I'll say 2 A's may not come, 2 B's may not come, 2 C's may not come, AB, AC, BC. These are the possibilities which cannot come there. Answer is 6. Out of 9 elements, 7 is to be selected. So which are the 2 things which are not selected? Can I say AA? Can I say BB? See, why should I select 7 here? उससे बढ़िया जब मुझे 7 select करना है और 2 reject करना है, why don't I take the cases of 2 rejection rather than taking a 7 selections here? सर आपके सामने 9 चॉकलेट्स पड़ी हुई थी. आप कितने तरीके से 7 चॉकलेट सिलेक्ट कर सकते हो? इसका मतलब ये होता है, in how many ways you can leave 2 chocolates? What are the 2 chocolates that you can leave? Can I say AA, BB, CC, AB, AC, BC? If you are not picking up them, that means you are picking up the rest of the 7. Is it fine? अरे भैया तुम लोग हाँ ना कुछ तो बोलो यार. Are you there? Intentionally I have taken this question. Reason is because many a time we get confused कि 5 selection कैसे करूंगा, and there will be many cases which will be coming there. ठीक है, फिर भी मैं diagonal वाला क्वेश्चन एक बार आपको दोबारा बता दूंगा. I'll discuss that question in the next class. This question I need to take up. I think others are clear. बाकी सारे clear हो गए होंगे. ये वाला भी मैंने आपको बता दिया. ठीक है, this question I will give you some method, some easier method. ठीक है, बाकी ये तो हो गया था number of diagonals. ठीक है, okay, thank you, bye. J7 and J8 I will be sharing another ID with you for the LRDI 5 class. Fine, okay.